pleasure to be here. It's interesting to hear all about all your varied backgrounds. I'm sure you're going to enjoy this summer school very much. I, of course, just picked the title, which is very obscure, and I hope by the end of this little talk you'll understand what I mean by my title. And I'm going to talk to you about this whole notion of visual analytics and big data, which happens to be one of the terms of art these days. And I'll do it in about 4 different parts. I hope all of them make a little sense. I hope all of them guide you not only in what you're going to be learning this week, but what you will try to do with visual analytics when you return to your regular day jobs, and also as you think about visual analytics in the future. If anything, I'd like you to think about this topic in the future. I'd like you to think about how it's used, how it can be used, what it means to you now, and what it will mean to you in the future. You're going to learn a lot of stuff. You're going to see a lot of tools and get a chance to play with some tools and actually do some exercises. But as you do that, I'd like you to think about what you will be doing in the future. And I'd like you to think about how you can contribute to the science of visual analytics in the future, if there is a science of visual analytics. And I'm hoping you'll find out a little bit today and also throughout this week that there is a science, and there should be a science, and it should continue. So, where do we live here? We live in this huge digital world. Bits, bytes, all sorts of things, ones and zeros. You know, the world looks a lot different these days than it did just a few years ago. And as we think about this large digital world, I want you to think about this in terms of context and problem statements and other things like that. So, I like to do this every once in a while, and I think about the last time I did this was 3 years or so ago. I'll leave this list with Ian so that all of you can actually think about this in the future. I like to think about the past and the future and what's going on, what we're doing now, and how we view things, and how we might view them as we go on into the future. I'm going to use this little list of past and present, or as I call it, what's out and what's in, which is a common thing that we do in the United States. Every year or so, there's always a list of who's in and who's out. Well, all right, let's think about this in terms of what's in and what's out. And I'd like you to think about this whole field of visual analytics in terms of this list. It's pretty helpful. What I'm hoping is that throughout this talk, I'm going to mention almost every one of these terms, and I'm going to tell you what I think about it. And I'm going to tell you what perhaps you might think about it. And at the end point, what I'd like you to do is think about how, if you were to create a list about what's in and what's out, not only for visual analytics, but for what you do, that you think about it as we're going on, and that you do it now, and that maybe you do it also on Friday at the end of the course. And I'm hoping that the list will have changed, that your own perceptions of what's in and what's out will have changed by Friday, and that you get a more complete appreciation for what we mean by visual analytics and how you want to use it. This will look, some of you probably have already memorized it. I can't remember any of it. But what I'd also want to let you know is that this appears throughout the talk. I use it to sort of introduce a new set of slides. So you don't have to try to remember all of it. But one thing I'd like to talk to you about is that there are some things that we're used to talking about now, like clouds and big data and data deluge, which may or may not be significant or impactful in the future if we consider, and think about visual analytics in the right way. But that's for you to decide. And you'll see some other terms up here that may or may not make sense. For example, cognitive and perceptual science, and you're going to hear about a lot of this from Brian. You're going to hear about other things that have to do with professionals and perspective analysis. But there are some other terms that I've introduced that I hope will make sense to you as we go forward. And I'd like you to think about them that way. Bourne Ultimatum is probably a pretty good movie to see if you think about visual analytics. Minority Report was okay several years ago, but things change. They change awful fast. And so I say that because I think back to my own past, my own experiences. I'm not sure if my bio says it, but my background's physics and biophysics, molecular biology. The reason I got interested in biophysics at that point was just this particular activity. On the left is an X-ray diffraction diagram of a double helix of DNA. You've probably all seen this, or if you haven't, you probably know about it as part of scientific history, 53, almost 60 years or so ago. What's interesting was, in the analog world, analytics was, at least scientific analytics and visual analytics, was fairly simple-minded, but it was very, very powerful. Just that array of dots on the right-hand side, which is where X-rays were scattered by, in essence, a solution of DNA molecules, told Watson and Crick and Rosalind Franklin and a few other folks that the structure of DNA was a double helix. They talked about its periodicity, it talked about its spacing, it talked about an awful lot of, just a few dots. This is analytics in the analog world, but we now live in a much more complex and much more confusing, and in some cases, less differentiated digital world. And we've got to keep that in mind as we think about visual analytics. I always like this picture, so if you want, you should read the story. So, what happens? Now we have this whole problem of data deluge. That is, there's too much. The reality is, are we looking for needles in a haystack? Are we fishing for something useful in a pile of trash? The deluge is huge. At least that's how we characterize it. We characterize it from the standpoint of much too much data. And several of you talked about having lots of data that you're worried about dealing with. Visual analytics is a way to address that problem. But in my view, and as might become evident as we go forward, it's a lot more than just a data deluge. It's a lot more than just massive amounts of data. It's a lot more than just trying to find some one thing that's relevant in a huge amount of information. And the fact is, even if you do that, even if you collect everything, it doesn't mean that what you have is what's useful to you. As Borges says in this one of his early stories, written I think in the 40s or so, just collecting all this information doesn't mean that you know what's there, and that if you apply the tools that are available to you, you'll be able to understand it completely. All it means is that you've acquired the possibility of knowing what's there. What the tool should allow you to do, and your interactions with all that information should allow you to do, is actually be able to determine what is relevant for what you are doing. Not that you understand all of it, not that you have access to all of it. All you've gotten is the possibility of knowing what's there, but not what's important to you. And the tools that you will hopefully start using this week, and as you mature in this field in the future, as you start developing tools, they will teach you how to pick out what's relevant and what is important to you. That's a problem because there is a lot of data, and it's always nice to give some sort of information. And these are nice numbers, and they come from somewhat reputable organizations in the United States. Although Berkeley's, I'm never sure. Having been there in the 60s, I could never tell what in the world Berkeley was doing. So, all I can say is that there's an awful lot of information, exabytes, zettabytes, however you want to spell it. It's rising and increasing at exponential rates. The thing that's most important for you to remember is that most of it is unstructured. It doesn't exist in databases. It doesn't exist in records. It exists in huge unstructured forms. A lot of it is images. But as we go forward, more and more of it will be all sorts of unstructured information, text data, and social media. All those kinds of things that you use now, but will become more and more important as a way to convey information, not only for intelligence analysts, but also for business and everyone else. It's going to be large, it's going to be moving quickly, it's going to be changing quickly, and there's going to be more and more of it as we go forward. It's an awful lot of information. It's unstructured. It has no easy features for you to use. So if you think back to that quote I gave you before, you will have the possibility of collecting it all and having some access to it, but you won't know what's relevant in it, and you need to keep that in mind. And when we started this activity back in the early 2000s, and even before, with some work that we did when I was at the FBI with Jim Thomas, there was just a lot of it. It was text. We wanted to understand it. How could we use it? How could we deal with it? This is important for you to think about. For me now, in the Department of Homeland Security, the reason this is important is because intelligence analysis, which is where we started all of this back in the 2000s and before, actually was the main focus of this activity. Some of you are here from government agencies involved in intelligence analysis. But this whole notion of homeland security, to me, has confounded the issue, if not confused it. Because now we have a whole range of concerns that people need to worry about. We need to talk about not just things that have happened in the past, not just specific analytical desires that we have, but long-term and immediate effects, from terrorist actions to global warming, to slow catastrophes, to large-scale changes in environmental stability, in food, in water, all those kinds of things. Nuclear devices have long-term effects. How do we understand them? Not just prevent them, but how do we understand them? How do we moderate their effects? How do we respond and recover from the effects of these kinds of things? How do we respond and recover from economic instability? All of these issues are huge issues which involve the collection of a lot of information, only some of which is relevant at any one particular time, but may always be relevant in the future as you go forward. It is important for you to realize that Homeland Security, at least in the past few years has introduced a huge number of new dimensions to this problem of information analysis, intelligence analysis, and the potential for the application of tools like visual analytics. And in my mind, visual analytics is really one of the only ways in which we can understand this. It is one of the only ways that we can look backwards. We can look at a situation as it exists right now, or as it is occurring, and we can look forwards so that we can project into the future what the consequences of other folks' actions, but especially our own decisions, might be. Visual analytics allows us to do that because it allows us to correlate large numbers of different kinds of information. And I want you to think about it in that form. And you think back to that previous list of the data. Think about it in terms of unstructured data. Think about this in terms of imagery, photographs, video, text, database records, instrumentation data, all those kinds of things that come into play. And think about all of this Homeland Security and also other things as how you put all of that together and get a more complete picture of what has happened, why it happened, and what may happen next. And understand the effects of any decisions that you make, any judgments that you make. How can we see that? Visual analytics is a very powerful tool in which to do that with, and I'm hoping that some of the exercises you're going to see this year will allow you to do that. Nisha said it will be very, very hard. We were talking last night at dinner. She said, worked up with something really disastrous for all of you to work on. That was while she was eating a pile of rice covered with huge red chilies. I just couldn't understand this. So, these are real concerns. These are concerns that I care about because I work for the Department of Homeland Security, but these are concerns that are just analogs for the kinds of things that you probably deal with every day and will be dealing with in the future. Think about it in terms of your own domain. Think about your domain in terms of what's out and what's in, where this will matter to you. Try to understand this problem, or try to understand your problems in terms of this kind of analog, and lay it out. It's the best way to deal with this kind of thing. So, you can't see that one too well. Here's some more pictures of data volumes that occur in 60 minutes in an emergency response scenario. It talks about information about transportation, surveillance, people and emergencies leaving sports venues, all kinds of things, the amount of information that's coming in social media sources. These are things that you can collect from the web. And these are things that we tried to collect just to give folks a feel for dealing with a situation response, a crisis, an emergency, and try to lay out all the kinds of things that are happening. You'll have copies of these so that you can see them a little more clearly. Here's another way of presenting this whole amount of information, but the truth is, as I said, large amounts of information, large numbers of people, all involved in various activities. First responders, as we call them, all sorts of people involved, all sorts of people who will be communicating with each other, trying to understand a crisis, trying to understand an emergency. And that's another aspect of all of this that you need to think about. It's just that it's not you only interacting with this information, but you interacting with other people who will be looking at their own sets of information. How does one correlate? How does one decide what information is relevant? What information trumps other information? Whose information is better? Whose information should be more valuable? Whose information should be used first? or second or last to make a decision. It's not just you and information that comes into play here. It's also how you interact with everybody else and how your tools interact with the tools that everybody else is using. So not only are you living in a very complex environment of data, but you're living in a complex social environment in which you need to use everything available to you, either at your desktop or on the desktops of other folks, to make decisions and deal with information. And if you think about visual analytics allows us finally to put all that different kind of information together, all those different people together to deal with a crisis. So, why did we start doing all of this? William mentioned it early on. He talked about how we started our work with PNNL and then ultimately with what we call the RVACs, the Regional Visualization and Analytics Centers, one of which is Purdue, and David and Ross will be talking about that. Richardson will be talking about the work at PNNL. Realizing all those things that we just talked about, we started an activity in 2004 to actually set up a variety of capabilities. The reason I show this is that this shows you that what we are trying to do is deal with this from the standpoint of not only a national laboratory like the National Visualization and Analytics Center at PNNL and RVACs, or university-based systems, but also relationships and interactions that we've had with comparable activities going on throughout the world. We also worked with our own National Science Foundation to develop what we thought was very, very important for the science of visual analytics, which is the foundations of data and visual analytics. That's what the FODAVA activity addresses. What are the mathematical and computer science foundations for doing visual analytics? Can we create a set of those kinds of scientific foundations for moving forward in this? Visual analytics is not just, in other words, a set of tools that you bring to bear on a problem, but it's also how one develops those tools. And so we determined that that would be very, very important. And at some point, you're going to need to think about this also. Textbooks are already out of date. As soon as they're written, they're already out of date, and they make it very difficult to learn anything. The practice of visual analytics depends on understanding foundations, math, computer science, and I would suggest others, such as cognitive science and even language. All of those come into play as you think about visual analytics. All of those come into play when you think about expanding this research complex that we've created. William showed it, same map. I'm not sure if it's to scale, but it's certainly not geographically located properly. We're all islands, according to this. But in any case, there are a lot of people working in this area. What I'm hoping is that over the next few years, more and more people get involved in this kind of activity, and that the community grows. The existence of the VASS conference is one ideal demonstration of the fact that scientific community in general has recognized visual analytics as an important area for work and wants to continue on with it. But not only the scientific community, but also the commercial community. All these companies are getting more involved in this kind of work. There's actually a company called Visual Analytics, which we found out when we tried to establish the, well, we knew it, but when we tried to establish the National Visualization and Analytics Center, they wanted us to license their name. Our lawyers managed to work around that one. But this has been going on for a while in various places, and more people are getting into this area, and more people are trying to determine how to use visual analytics And as we think about developing cooperative agreements with other universities and government agencies, we also need to think about developing cooperative agreements and memorandums of understanding and other activities with commercial firms and potential users, such as the Port Authority of New York and New Jersey, so that we are all working together in this activity. One of the things that we found over the years has been that we should get involved with user base almost immediately when we are trying to develop and implement visual analytics tools. It is that real-life interaction that determines the effectiveness and utility of some of our tools, that tells us what we're missing. This is not all a scientific exercise, but it's also an exercise in which you try to make tools and your concepts operationally relevant. And so what I'm also suggesting that all of you think about as you go forward in the future is, again, how you can interact almost immediately with some user base, some operational entity that will be using those tools, and not just yourself, but other folks, so that they understand how they can be applied. I've got a bunch of slides that talk about some of the tools. I think you're going to see some of these as you go forward, from heat maps to link diagrams to all sorts of things, to theme diagrams, all sorts of tools that allow you to take either static information or a stream of information and lay it out on some two-dimensional or 2.5-dimensional grid to have you understand it a little better. You're going to play with all of these kinds of tools. You're going to have an opportunity to see more and more of them. And then what you might also get to is actually trying to view this from the standpoint of what we've come to call now precision information environments, and the live wall, ways to interact with data, not only with data, but also with other people using data. So as you think about visual analytics tools and tool sets, think about how they will be used, how they will be implemented, how you can use them along with other folks. They need a framework in which to be used. And a lot of the work that will be done in the future is developing frameworks for interacting with data, but also with other individuals, and doing it in real time. If you think about these tools as analytical capabilities, fine, but think about them in terms of capabilities to synthesize information in real time as a situation develops and as you make decisions about that information. And for that, you need much more than just a tool on a desktop. You need all sorts of tools that at this point have not been put together yet. You need a variety of tools that can manage all this information and manage all this interaction and manage all this decision-making and hypothesis testing. If one works in just that area and makes these tools easier to use and collaborate with, one will have created a great deal. So, that's context setting. Now I got another section of things to talk about, which I'm going to call current solutions. I show my what's in, what's out slide again. Haven't changed it. Just wanted to refresh your memories. I wanted to talk about tool sets and retrospective analysis now. I want to talk about analysts and Homeland Security professionals. I want to talk about all these kinds of things and see if we can tell you what's going on right now. The next section will talk about where I think we should be going, and then I'll do a wrap-up on all this stuff. But I'm just showing you this what's in, what's out slide again, just to keep you thinking. And paying attention, there are a lot of the terms that I've used so far appear on this slide. and some new ones will appear as we go forward. All right. What I'm arguing for, and what all of you, I would hope, come away from this topic with, is this notion that it's better to be prospective than retrospective. Intelligence analysis for a long time has been retrospective. And it looks backwards and it says, well, this is what happened, this is kind of how it happened, and maybe we figured out the reasons for it and the causes for it. But in reality, as we move forward, as we think about all this vast quantity of different kinds of data, we need to do something with it. We need to be prospective with it. Now, I use prospective. Occasionally I'll say predictive, but predictive always means that you've got some sort of number or value that says, I'm going to predict this with some percentage of accuracy or some reliability. That's kind of hard to do right now, so it's very difficult to be predictive that way. We're talking about being prospective and not thinking about any things being possible. Anything is possible, but it's what do we think might occur? Why do we think it might occur? And especially, how can we deal with it with the notion of massive data and multiple modes, multiple types, coming from multiple devices and being used in diverse environments, and in order to make decisions in real time. Actionable is a term you're going to hear a lot. It's been a term of art for years. It still seems to go forward. You want to make decisions, you want to have those decisions lead to actions, and you want to know why. So this is kind of what we're talking about. But having said all that, there are two things that really matter. The first set of things is something I've hinted at before, but when you're looking at a set of information, you need to be able to determine what's relevant. Are you missing something? What does it mean? When will I need it? Do I need it now? Did I need it an hour ago when something already happened? Will I need it 2 months from now when I'm trying to figure out what to do with a pandemic? How do I use it? What use do I make of this information? Another thing that's extremely important is, can I trust it? How reliable is it? For us working in the government, privacy is always a concern. For each of you, privacy should be a concern. But we've got to understand, is this information private and personal? Especially if I'm sharing it with somebody else, and I'm not exactly sure with whom I'm going to be sharing it. How do I convey this information? How do I convey my decisions or judgments to other folks? When can I take action with it? When do I have enough to take an action? And which actions do I take? How will other people see the information I have or the information I have analyzed or synthesized together? How should I interact with it? These are questions that need to be answered when you start dealing with information and as you start applying visual analytics tools to it. Most of the tools that you will play with don't answer any of these questions. Some of them will, but until you actually get to the point of being able to answer these kind of questions, you have not used visual analytics to the extent possible and to the extent that makes the best use of information. It is these kind of questions that you need to think about, and it is these kind of questions that can be addressed through technologies, that can be addressed as features or other aspects of visual analytics tools. Very few tools at the present time have these kind of features but how will you be able to actually incorporate these kind of features or develop new tools that do this in the future? And as you think about visual analytics in the future, think 5 years out, 10 years out. Some of these will take a long time to develop, but that means there's a lot of work for every one of you to do in the future. Because until you can do something like this, until you actually understand information after analytics, it doesn't become as useful as it can be. It does not become as important or impactful as it should be. And there's a lot of work to be done here. And as you go through this week, look at all the tools that you're going to play with and the exercises that you are given, and try to figure out, where would these kind of questions apply? Where would I introduce these tools or features that would allow me to do these kinds of things? And then there's another whole set of things you need to think about. Archiving, permanence, rendering, regulatory or legal issues. You know, paper seems to last a long time, almost 3,000 years, and 2,000 years, something to that effect. How long are those digital bits going to last? How long are those things going to last? 10 years? What bits of information do we not care about? When we start to re-record it, what bits should we keep as we continue to create more digital data, and then we try to replicate it? How are we going to replicate what's important? How do we determine what will be important? How will we know what may be relevant down the road? Think of any epidemics or pandemics. Think about economic instability. Think about all those things that in many cases didn't become important until decades after the fact. How do we keep it? What are we going to do about it? What do we do about clouds, warehouses, and websites? Who runs those? Who can speak for the reliability of this? How long will one of these things last? How long will a DVD or a CD last? In terms of physically, how long will the little bits of data on this last? Can any of you? When I joined the FBI, all our stuff was, well, when I first joined, it was all run card catalogs. But then we moved to mainframes. I like card catalogs. They last a long time, but they're hard to deal with in terms of manipulating. But then we moved to mainframes. We had a lot of data sitting on old IBM mainframes, running EBCDIC code and things like that. Do you think anybody can recreate that data now? Can you render it again? How do we make sure that what we've stored and created in some format now will still be able to be recreated 10 years from now? Well, let alone 50. It's been a long time. And most of it doesn't last. What will we do? Emulating old computer systems is not foolproof. It doesn't work. How are we going to do this? It's easy enough to play with. And then there are all these regulatory and legal issues. All right. So these are issues I want to think about. But think about this. So now I'm going to do this real quickly because it's this is the philosophy part of this talk. So you'll have to excuse me for this kind of thing, and maybe Brian will understand. Look, the reality is we need to find some way to deal with information and deal with it in a new way. We've thought of it in terms of duality in the world, and the world is text. Everything is being text. Visual means bandwidth, representation, things like that. What we have to understand, and what you're going to learn about now, is that human cognition is extremely important in dealing with information, especially visual information. I'm sure Brian's going to give you a set of wonderful lectures that describe all that and explain it well. The point is that human cognition is an extremely important part of data and information, and especially visual analytics, and that perception is extremely important. But if you think back, most of the perception and how people used perception when the human race was evolving was that it was all focused on action and cognition. You understand something, it's embodied in an action. It is not so much some sort of thought experiment, it is an action. And when we think about information and think about presenting it visually, you should be able to think about it in terms of not just presenting it as a graph, not just presenting it as a visually abstract idea, but think about presenting it in a way that action is embodied, a decision follows, something occurs with it. And as you develop visual analytics tools in the future, you need to think about it that way. We need to think about visual analytics as a behavioral tool and as a behavioral language and as something that enables you to make a critical judgment. From that critical judgment, decide what's going to happen, and then find ways to explain to you what the possible actions are. I'm sure Brian is going to explain all of this much better than I have. But I want you to think about it in terms of cognition, and I want you to think about perception in terms of embodied actions, and not just diagrams and images, things like that. What we are thinking about, in other words, is decision-making and judgment. What we're thinking about is the fact that most of our interaction with information as we have evolved has evolved because we've taken an action. And instead of thinking about it in terms of propositions, we've thought about it and we've dealt with it in terms of heuristics. We do something, something happens, we see what happens. It's an experimental approach toward things. So that what we really want to be able to do is move beyond data, information, knowledge to wisdom, beyond just discovery and aggregation and integration, and to some sort of synthesis of data, some sort of prospective or predictive view where cognitive or behavioral analytics is exactly what we're talking about, and that the visual medium is the way in which we enable that to occur. Connecting the dots is a fairly low-level activity. For those of you who remember the 9/11 Commission report in the United States, they focused a great deal on the failure of the U.S. government to connect the dots. But even if we had connected the dots, I'm not sure that we could have made the decisions that would have been necessary to stop the terrorist attacks in 9/11. And especially as we look at more complex problems in the future, connecting the dots is not the answer. And if all we do is look at visual analytics tools as just being able to connect the dots, then we are missing where they can really be applied and how they can be applied. We've got to understand context. We have to understand culture. We have to understand our own human DNA, our own evolutionary abilities to take advantage of the full measure of visualization and visual analytics tools. And it will allow us to move beyond integration of data and organization of data to actually being prospective and predictive and having policy come out of it. This is potentially a complex chart, and it perhaps is wrong-headed, but that's for you to decide. This is how I view life, and I need you to think about visual analytics and behavioral analytics in the standpoint of what you really want to accomplish with information. So, here we are again. Same tools, same what's in, what's out kind of thing. We've been talking about precise data. We've been talking about massive amounts of information. We've been talking about cognition and perceptual science and global uncertainty. What really matters to me is not huge amounts of data. What really matters to me is not the fact that this data comes in multiple forms, but the fact that most data and most data that you see now and most information that you will see in the future is extremely undifferentiated. It exists as the Library of Babel from a story, that term taken from a story by Borges, in which he described a library of all the world's information. The problem was it existed in a never-ending set of rooms, all the same size, 6 sides, all of them having book racks. Each book rack had 5 shelves. Each shelf held 40 books. Each book was 240 pages long. None of them were identified. The problem is in that view that there's all this information, it's undifferentiated. It's not that it's infinite or large. It's the fact that it's undifferentiated. How do you pick up the distinctive information that's necessary? The world is becoming to look like the Library of Babel. How do you extract meaning from all of that undifferentiated information? How do you develop tools that enable you to do that? So, my way of dealing with all of this is, since I'm arguing to create a science of visual analytics, is that you actually create some principles. So I have 3. One of them is the principle of information. The problem or need is basically that we have large amounts of data with increasing diversity. It's multiple, it's diffuse, it's used by all sorts of people. They want to use it in real time for decision making. It's indeterminate. That information is not immediately obvious. What is going to be important? Potential threats. You have to understand this problem in terms of this information. And in the United States, there are 80,000 law enforcement agencies who might want to use this. So that's a big problem when you think about collaborating with everybody. So that's the principle of information. Then we have a principle, the second, is the principle of utility. That is, not only do we want to be able to analyze single types of information, like imagery or text, things like that, but we also want to address this in terms of as it scales. The goal is to be able to do this immediately, in real time. How can we do it as all that amount of single kinds of information scales? How do we increase or integrate all that information? That is, how do we deal with the heterogeneity? How do we combine all that streaming data or sensor measurements or things like that with all that kind of information? That's dealing with complexity. And how do we create dynamic analyses of streaming information of multiple types? That is, how do we enable decision making on multiple levels? If we're going to make information useful or have some utility, we have to address all of those things. And visual analytics tools have to address all of those things. And we have to do it because there's a last principle, which is outcome. That is, in the Homeland Security environment, how do we understand threats in sufficient time or to a sufficient degree to prepare or respond, to mitigate the effects? How can we predict the scale or scope of these kinds of issues? How can we accurately, or more accurately, gauge not only their immediate effects, but their lingering effects? And I mean lingering. Problems will be lingering. All those big Homeland Security concerns I've talked about, and a lot of things that you will be addressing in the future are long-term. They will have lingering effects. How do we understand them? Not only now as we make a decision, but a day from now, a week from now, 10 years from now. How do we know what we're doing with them and how well we've been addressing them? Our tools need to be able to do that, and our visual analytics tools need to be able to do that. So those are 3 principles that I'd like you to think about, and I say that these are the 3 principles that determine the science of visual analytics. You're welcome to actually come up with more or to suggest changes to all of these, and I think that would be a useful exercise for you to do. So, what we really want to do is, in other words, have a goal in mind, a coherent story using complete, up-to-date information and that we're comfortable with in making decisions. So use those principles, see if we can do this. But we want to know how coherent that story is, how complete it is, how current it is, and how comfortable we are in using it. So ultimately, if we apply those principles, we still need techniques that allow us to introduce confidence limits and risk measurements for our decisions. Those don't exist at the present time, and those are yet to be described, not to the extent, at least they don't exist to the extent that I think is useful. If we're going to create coherent stories, we've got to be able to explain risks and confidence limits and things like that. Our tools have to include that kind of stuff. We've got to make sure that we are not only dealing with Babel, but that we are making some sense of information, that we are actually talking about information and using it in terms that we can translate to each other. In other words, in Wittgenstein's terminology, we can't speak about something, we just have to pass over it in silence. I've tried to make the connection to the title. Okay. So, what are we talking about? The future for analytics, and visual analytics specifically, means incorporating new features. What I've been trying to argue with all along is the fact that we basically have capabilities that allow us to deal with these 10 things. Utility for long-term, large-scale issue, confidence limits, measures of risk, ability to address interacting or cascading effects, especially with critical infrastructures, a real-time view of dynamic or streaming data. Reach back so that you can determine in what I call incipient relevance to information. A system or a holistic view, all of these things that you have here. Accurate timings for perspective views. As we develop the science of visual analytics and we develop the tools that embody that science, these are the kinds of features that we will need to expect from our tools. And these are the kinds of features that you, as you go forward, should be looking at. So, what do we need? Dynamic rather than static views. We need a language of visualization. That is, something that can be translated. Just as we use translation to move from language to language, from coordinate system to coordinate system, from one type of analytical capability to another, we need to think of visual analytics in terms of a language and how we can translate beyond it. And we need to have some sort of measure of the effectiveness of our visualization or visual analytics capabilities. I call it the move value, but I created principles. I may as well name it something. So, it's up to you to actually come up with other ideas on this. If we don't accomplish this, then visual analytics will be a tool set or suites or things like that, but ultimately it needs to become a science, and it needs to be formalized and systematized, and it needs to have some way to measure its effectiveness, and it has to have some way to measure how you can translate information that you get from one visual system to some other kind of system. That's what we need to create. We need to address foundations in that kind of terminology. So that's what we're looking for in the future. That's what we need to do. It's your idea. You have a chance at the end of this week to actually fill out that form and decide what's out and what's in. I gave you 3 spaces. You can add more if you wish. But I'm going to ask Ian to actually make sure that you get copies of this so that you can print them out and just try it. It's something that you can do right now, and I think it would be good for you to think about it and do it now, and then do it on Friday afternoon. See if your mind has changed. See if your ideas have changed. And in order to help you with that, just read these books. These are ones I've been reading the past 2 or 3 years. The Bellows book about translation is fascinating, but there are a bunch of them. This is just it's not an assignment, it's just a list. It's obviously available in my talk, so think about it. It's actually very good fun, and I'm glad that we're all here and we're all trying to collaborate. Thank you.